still it was incurred with several problems, and they were just like this. Point 1. RDBMS cannot host for large magnitudes of data. Literally, if your data is at the range of hundreds of terabytes or petabytes, you will experience RDBMS with a very degraded performance. The most important problem. And next 2. RDBMS will not give you any support for the unstructured data, which is the most important. When I specify like unstructured data, the data on which you cannot define any schema is nothing but the unstructured data. Simply images, video files, audio files, XML files, JSON datasets, PDF files. So these all fall under the category of unstructured data, where RDBMS will utterly fail in handling those unstructured datasets. But still, we are working with that because we don't have any alternative. And above all, it's a well-known fact that we usually opt the disk space from SAN, storage area network, where we'll get the disk space as the LUN allocations, logical unit allocations, where the largest disk size would be at the range of 24 terabytes. And if we talk about the constraints involved with the range of storage on the whole, or like this. Point 1. There is no support for unstructured data. 2. It is very expensive because of the SAN storage, where literally we will be using FC disks, fiber channel disks, or SSDs, solid state drives, which are very, very expensive. But still we are just moving ahead with them because we don't have any alternative. So on the whole, data storage is very expensive because of high-end hardware, and we cannot expect any support for the unstructured data. These two are the most sounding constraints at the range of data storage level. And of course, once after the data was stored, definitely you need to process it, for which ETL, data warehouse, and SAP, as we discussed, everything comes under the picture for the processing of the data sets, analyzing them, where these SAP solutions or data warehouse technologies, they will not work with cheap hardware again. They literally require blade servers and Spark processors to work on, which are very, very expensive. And at the same time, majority of them were not open source. You need to purchase the license, which will even increase the cost constraints. So simply, data processing is very expensive because of the licensing issues and the high-end hardware. That's the problem with the data processing. And above all, if we just delve much more deeper, if you want to process the data sets, initially you need to transfer it from the storage centers to the processing units, for which you need to seek the help of network. And the word network will give you a dump of constraints again, where using FC cables, fiber channel cables, you can achieve a transfer speed of almost 16 Gbps. Excellent speed, excellent transfer speed. Though the data could be transferred at 16 Gbps, the problem is your disk cannot retrieve it at that much fast. 16 Gbps is your network transfer bandwidth. Excellent, but your disk speeds are hardly struck at 500 Mbps, and so leading to your bottleneck problem. This is the most important problem. And then we know that we usually go for Unix or Linux flavor of operating system at the storage, where we usually opt for Solaris, AIX, or HP Unix, any Unix flavor of operating systems, where the block size is of 8 KB. Let us discuss like this. Let's say that you would like to store 64 MB of data. After all, for storing 64 MB of data in the Unix file system, it will consume 8,000 blocks because the block size is of 8 KB. And if you want to retrieve your data back, your disk head need to be moved from one block to another block and so on 8,000 blocks. And the time taken by your disk head to retrieve your data from one block to another block is what we call as disk seek time. Because the block size is less, seek time is huge. So on the whole, if I talk about the existing methodologies, let me talk about the constraints involved at each and every level, and let me list out them. Point 1, we cannot expect any support for unstructured data. Point 2, disk seek time. 3, network issues. And 4, expenses. So these 4 are the most sounding constraints. So literally we require a new alternative, a new technology which will support the unstructured data, which will eradicate the disk seek time, which will vanish the network constraints, and that new technology should not be expensive. And that new technology which had these features is nothing but Hadoop. The main reason why I am delving deeper and addressing much about the data is over here. I'm sure majority, I'm sure again, majority would have heard about this. IDC, International Data Corporation. According to the statistics of International Data Corporation, the world's data in the year of 2006 is 0.18 zettabyte, where in the span of 5 years, that is in 2011, it increased 10 times and it came to 1.8 zettabyte, where by the end of 2020, which is almost 5 years ahead from now, they're expecting the data to reach 40 zettabyte. And I'm sure 40 zettabyte is not a simple figure. It's a huge, and here I mentioned what a zettabyte is. So 1 zettabyte equals to 1024 cube terabyte. Let us make it approximate, so which will be of around 1000 cube. That means 10 power 9 terabyte. So 40 zettabyte equals to 4 into 10 power 10 terabyte of data. So this is the magnitude of the data by 2020. Just imagine how many 24 TB drives do we need in order to store this magnitude of data. Not only storing it, we need to provide the redundancy also. And how many $1 million do we need in order to process this magnitude of data? And how many days do we need in order to transfer this with the existing bottleneck problems of the network? The thought itself conveys is that we are choosing a wrong path. We need an alternative. And above all, 80% of this data is going to be unstructured, where we the people are generating this unstructured data. Usually uploading images, videos, likes, comments, shares, tags, applications, tweets, chats, posts, whatnot. Everything in the social networking websites, and generating a huge magnitudes of data. And we classified mails as semi-structured data because if you consider an email, You will have to CC, BCC and from. Well, you can define a schema on the mail ID and you can store it, not a big deal. But can you define any schema on the text body of the mail? And if you observe, majority of the mails may have attachment and many may not have any attachment. And that attachment might be again unstructured. It might be an image file, it might be a video file, it might be audio file, but the mail IDs are structured. And the machine's unstructured data like RFID readers, GPS traces, and the log files, where especially I'm addressing about the access log files. We know that we usually disable the access log files at the server level because they will be generated at huge magnitudes. But if you have the technology to deal with these log files, you can make money out of this dump. A simple example, we processed the log files of Flipkart and we generated 38.6% of their revenue. That is again through Hadoop. So let me share you, it is Hadoop which can handle this magnitude of data, this magnitude of unstructured data in an excellent way and help the organization to make money out of the scratch, money out of the dump. Because till now the unstructured data is simply being discarded. But now it's the time for the organizations to analyze their unstructured data and to make money out of it. And before sharing what exactly Hadoop is and how Hadoop can handle these things, let me talk about this term, big data, the most sounding. Well, big data is not a technical term actually. Big data is not at all a technical term. Any data having several characteristics could be addressed as big data. It is volume, velocity, and variety, where volume indicates the magnitude of your data. Whether your data is at the range of terabytes, petabytes, exabytes, or even at the range of zettabyte. Velocity indicates the speed at which the data is getting generated and the rate at which you need to analyze that generated data. And variety talks about type of the data, whether it is structured, semi-structured, or unstructured. If your data is of huge magnitudes, which is semi-structured or unstructured, and getting generated at high speed, you can address your data as big data, which is $1 million question in front of the industry. And it is Hadoop which can handle this unstructured data in an excellent way and which will overcome all the drawbacks present with the existing methodologies. And here it is. Well, whenever I spell like Hadoop, I need to address the most important term. Hadoop is always at a cluster level, where a cluster is nothing but combination of nodes connected across a network. And a node is nothing but a simple computer. So let us say like this. A cluster is nothing but combination of computers connected across a network. And when you install Hadoop on each and every computer, it will simply become a Hadoop cluster. So let's say that you purchased 100 computers and you installed Hadoop on all these 100 machines. Now yours is a 100 node Hadoop cluster. And the moment you install Hadoop, it will accumulate two major components across the cluster, which is nothing but HDFS and MapReduce, where HDFS is completely for storage and MapReduce is for processing. Let me talk about HDFS, Hadoop Distributed File System. The name itself conveys us distributed file system. Well, distributed file system is not new, it's old. It's a well-known fact. But Hadoop distributed file system is something new where the default block size is of 64 MB. Just imagine 64 MB block size is not a simple block size. Let's say that you'd like to store 128 MB of data in the Unix file system. Where at the range of storing 128 MB of data, you require 16,000 blocks because the block size is of 8 KB. The same 128 MB of data in HDFS will consume only 2 blocks because the block size is of 64 MB. Imagine about the disk seek time in case 1 and imagine about the same disk seek time in case 2, where you'll find a drastic difference. So since the block size is large, seek time is less. One of the drawback, disk seek time is no more on Hadoop because of the large block size. And since you are storing the data directly in the file system, you can have the privilege of storing the unstructured data. And that was the main reason why we could able to store images, songs or movies on your laptop or on your PC, because you are storing them directly in the file system. So the moment you upload a file, let's say you uploaded a file of 1 terabyte into the 100 node Hadoop cluster, that 1 terabyte will be literally made into 64 MB chunks, and those chunks will be scattered across your 100 nodes. It will be scattered across your 100 nodes. And if you want to process that, whatever the data which was stored across your 100 machines, you'll simply design a MapReduce job, where this MapReduce job can be designed either in Java, Ruby, Python, Perl, or even in C++. But since majority we have Java programmers, we usually go for Java MapReduce, where we'll simply make a jar file out of it and you'll make it to transfer, where it's your jar file which will transfer towards the computers in your cluster on which your data was stored. So it will store the data on your 100 machines and it will process the data on the same 100 machines. So literally you are storing the data on your cluster and even you are processing the data on the same cluster. Obviously it will not have any issue. It will not have any network impact. So network issues were vanished because you are storing the data and processing the data on the same cluster. And above all, whatever the machines that you are using in the cluster environment are of cheap hardware. Hadoop does not require anything like blade servers or Spark processors to work on with. It works with a very basic minimum hardware which costs nothing. And above all, Hadoop is an open source. So if you observe, on the whole, you have the support for unstructured data because you are storing the data directly in the file system. Disk seek time got vanished because of 64 MB block size. And since you are storing the data and processing the data on the same cluster, network issues were drastically reduced and your expenses got minimized because you are using cheap hardware and it's an open source. All the 4 constraints, what all we discussed earlier, were no more with Hadoop because of these features. What else do we require? This is what exactly Hadoop. And this is what I have been talking about. Data storage and data processing at one hub. And that hub is nothing but your cluster. And this is the fastest processing. This is not what Vignesh is boasting about Hadoop. This is IBM's declaration where we processed 1 terabyte of unstructured data with RDBMS, which consumed 28 hours to process it. The same 1 terabyte of unstructured data using Teradata consumed 6.5 hours to process it. The same 1 terabyte of unstructured data using Hadoop 180 node cluster could make it in 3 minutes 27 seconds. And the same 1 terabyte of unstructured data using same 180 node Hadoop cluster but with the latest architecture called as YAN architecture could make it in 1 minute 19 seconds of time. Just imagine the magnitudes. 28 hours with RDBMS, 6.5 hours with Teradata, 3 minutes 28 seconds with Hadoop, and 1 minute 19 seconds with the latest architecture of Hadoop. That is at the range where Hadoop can handle the things. And above all, you can make it at a cheap cost because of the cheap hardware and open source. This is how exactly the internal functionality of Hadoop will be, where let's say these are your nodes, these are all your computers, and here is your big data. The moment you want to handle this big data, you'll upload that to Hadoop environment where your data will be made into 64 MB chunks, and those chunks will be scattered across the cluster in this manner. You'll have your data scattered across the cluster in a distributed fashion like this. So if you observe, your data was stored across several machines, several computers in the environment. Let's say that you'd like to process this, where you'll make a jar file using Java or Ruby or Python, any of it, and you'll transfer it. So if you observe, your data is stagnant. You're not moving your data. It's your jar file which is moving towards your data sets. It's your jar file which is moving towards your data sets. Keeping your data stagnant. And if you observe, your data is getting parallelly processed across the cluster. It is getting parallelly processed. And if you still delve deeper, on each and every machine, it will still create further JVM instances. It will create several JVM instances where these JVM instances will partition the internal data into chunks, where each and every chunk will be carried out with one JVM instance. So if you observe, Hadoop is not a simple parallel processing, it's a massive parallel processing. Here you can see. That's what Hadoop exactly does. It's a massive parallel approach of handling the data sets. Where here you can see the core concept of Hadoop. It is easier to move the computation rather than moving the data. And that's what we have been doing here. Your data is being stagnant, and it's your computation which is being moved towards your data. And it's a massive parallel processing for the ease of handling the large data sets. And it is easier to deal with small data chunks rather than dealing with big data sets. So that's the main reason why it will internally partition the data. And above all, you can expect these things with a cheap hardware, which costs nothing. Any questions till this moment?
That sounds good.
If you could kindly give me then 2 more minutes, let me finish this topic as well.
By the way, the screen is refreshed, or because I still see the same picture with the elephant, or is it the same thing that we are looking at, or is it refreshed?
Are you not seeing anything like Hadoop ecosystem component?
No.
Really? Okay. Because I moved to the end of the slide.
Actually, it shows that you are offline, you are disconnected.
Just check your internet one.
Actually, I can see the Hadoop ecosystem screen.
All right, fine.
Well, I do have the network is good. Hold on a second, please. Yeah. Yeah, looks like I have some problem with the network.
Oh, okay.
I'm not able to connect, but go ahead.
Oh, right. So as I specified, once after the data was populated in HDFS, distributed file system, in order to process it, we'll design the MapReduce job where we can design it in Java, Ruby, Python, any programming language. But let's say for the people who are not from any programming background but still want to work on top of Hadoop, yes, there is an alternative for it. We have Hive, which has its own query language called as Hive query language, which was made on top of MapReduce. So here you need to pass a query, and that query will internally generate the MapReduce job. It's just like a tool on top of MapReduce. It's an alternative to design the MapReduce job. Just pass your query, and that will internally generate the MapReduce job for you. So you need not to struggle in making the lines and lines of MapReduce code. You need not to design any MapReduce logic. Just design your query, and that will generate the MapReduce job for you. It's an alternative to design the MapReduce job. And we have another alternative for the people who are not even from the SQL background. That is nothing but Pig, where it has its own scripting like language called as Pig Latin. And whatever the script you design, that will generate the MapReduce job for you.
How do you spell it?
Pig, P-I-G.
Oh, okay.
So Hive and Pig, these two are the alternatives to design the MapReduce jobs. They are simply the alternatives. And we have another ecosystem component called as Scoop, where Scoop is a utility tool to ingest the data from different RDBMS to HDFS. Where using Scoop, you can import the data from different RDBMS like Oracle, MySQL, SQL Server, DB2, even from Teradata, NetAsia to HDFS. So to fetch the data from different sources to HDFS, we'll be using Scoop. And Avro is to deal with the serialized data sets, encrypted files. And HBase is the NoSQL database. I'm sure majority might you had heard about this term, NoSQL or NoSQL. The name itself conveys us NoSQL, nothing but not only SQL. Where here you will not have anything like normalization, no primary keys, no foreign keys. It's not a row-oriented architecture, it's a column-oriented architecture where your data will be stored in key value pairs, and they have the capability to store your unstructured data. And of course, you have totally 150 NoSQL databases, out of which the most sounding are like HBase, Cassandra, MongoDB, Neo4j, Couchbase DB, Accumulo, Dynamo, Bigtable. So these are fall under the category of NoSQL. And Zookeeper is a coordination service which is used for the internal communication among these ecosystem components. Each and every ecosystem component, whatever I addressed till now, is an open source. Hadoop itself is an open source. But let's say that you're trying to build a 100-node Hadoop cluster. So you'll purchase 100 machines and you'll download Hadoop from Apache website. And you started working on top of it by installing. Meanwhile, you got an issue. You cannot expect any support from Apache. That's a well-known fact. And if you want to work with these ecosystem components of Hive, Pig, Scoop, you need to download from Apache website, install them, configure them manually. In the meanwhile, if you have any issue, no support. And since this is an open source, you cannot even expect a well-versed user interface on top of it. Majority is based on command line. So owing to these constraints, there were several organizations which came up where they will provide you excellent user interface, they will provide you a very good technical support, and they will offer all these ecosystem components as a package. Where some of them are like Cloudera, Hotonix, IBM Big Insights, Microsoft HD Insights, Amazon Web Services, Oracle Big Data, Intel Hadoop, EMC Square Screenplum, MapR distribution, and you have almost 14 distributions like this. And whatever the distribution it is, the basic concept is the same HDFS, same MapReduce, but the only difference you'll find is user interface varies from one distribution to other distribution, and their commercial part varies from one to other. And these are all the clients. Some of the clients who are following Hadoop, where by the end of 2015, next year ending, we are expecting almost 90% of this industry will be migrated for Hadoop, because they need to survive with this huge data sets. So this is an introduction, and if you have any questions, now you can unmute yourself and you can fire me with your queries.
Okay. What level of expertise is required in Java?
They need not to be a Sun certified Java programmer. Mm-hmm. Whatever they require is the very basic core concept of Java, core Java. Especially they need to have the knowledge of OOPS, exception handling, collection framework, generics, and serialization. Only 5. They need not to even know what exactly a servlet is. They need not to know that. Only these 5 are required to play with MapReduce. Because the rest of the things, Hive, Pig, they even don't require to know this part. They were completely the alternatives. To work with MapReduce, only these are required.
And does a consultant need to know any RDBMS techniques?
Yes, he need to have the basics of SQL, because he need not to know the things like normalization, primary keys, foreign keys, because we will not have such things in Hadoop. We will not have that, but he need to know the basic queries like a select query, how that happens by, and what makes the joins. Only those concepts, the very basics.
One last question, out of curiosity, I'm asking, how is this rendered to the end user?
This is not confined to the end user. This is always at the backend process. This is always a backend process where Hadoop is an alternative at the range of data warehouse and ETL. You'll find the impact at that level, which has no connectivity for the end user.
Okay.
Where you can redirect it to your user interface for the organization's user interface, where you can make it by the Thrift API. or the REST API. You can make it at that level, but it is not confined to the end user. You can use your front end designed in .NET or PHP or with Java or with HTML, no matter. It's an entire backend process.
Okay. Got it. And as far as the training part is concerned, like, how is this environment available?
As I specified, it works with cheap hardware. So we'll be creating a virtual machine on top of the Windows machine. We'll install the VM workstation and we'll load Cent operating system, nothing but a Linux flavor of operating system onto that. And on that, we'll play with. So whenever they feel like practicing, they can open their virtual machines and they can play with it because they'll have everything on their fingertips. Set up with their laptops.
Okay. Does the consultant need to know any shell scripting?
No, not required.
Okay.
Not required. They need to know the Linux directory architecture. That's it.
Mm-hmm. Okay, sounds good.
Yep.
How many classes, like, would it take? Like, let's say if you go at a speed of 1 hour a day.
It will consume 45 hours.
Okay.
Yeah.
Okay. Sounds good. So if the consultant, let's say, the consultant has a basic, does he need to have a prerequisite of Java expertise, or let's say if he doesn't have, is there any way you would give some tips for him to brush up, or to get to the speed?
Sure, no problem, because the way that they were confirmed, I'll forward you a document, a Java document, which will have all these basics required for Hadoop. They need to, and the document comprises of hardly 80 pages, 80 pages document, where they need to have a peek through that, which was completely discussed with examples. Just have a peek through that, and so they can get synchronized with MapReduce.
Sounds good. Okay. That would really help us, yes. Okay. Sounds good, Vignesh. I'm impressed with your demo. Thank you very much.
Right, thank you. Any questions from your side, Vijita? Yeah, please.
Yeah, actually, I mean, like, I have sort of very few basic knowledge, I mean, like core Java knowledge, but the thing is, do I need to learn more and deeper? And also, I have a doubt, like, we have to learn all the Hive, Pig, and Scoop. All these, do I need to learn, or just whichever technology I'm interested, do I need to go deeper?
So you are planning to build your career as a Hadoop developer, right?
Yeah.
So let me be fair, actually, majority of the organizations, almost 90% of the organizations will go on processing their data sets using Hive and Pig.
Okay.
They'll not use MapReduce because MapReduce is a programmatical approach where they need to require a programmer, and that programmer should have a skill of designing this code in an optimized way, and he should design the code in a much faster way, for which we need to pay them much. They're expensive. So in order to eradicate that, we look for an alternative of Hive and Pig, where a simple example, a single statement of a single Hive query equals to almost 120 to 180 lines of Java code, where you can conserve much time, you can conserve your resources, you can conserve your financial matter, everything matters. So that's the main reason why alternatives will be chosen always to go with Hive and Pig. But if the data is really complex, let's say it is encrypted, at that level, then we'll go with MapReduce partner. So that's the main reason why we need to have the knowledge of all these ecosystem components. And if you open any of the job portal, you'll find a combination of skill set. You'll find them like this: HDFS, MapReduce, Hive, Pig, Hive or Pig, any one among them. And you'll find Scoop, Uzi, and you'll find any of the NoSQL database like HBase or Cassandra or MongoDB.
Okay.
Yeah.
So in our course, what are the things we are going to cover? I mean, like just the echo components like Hive and
We'll
particular.
cover, no, we'll delve deeper. We'll delve deeper regarding each and everything. Whatever I cover will be the deeper discussion, except at the range of Cassandra and MongoDB, because I did not work on them. I worked extensively on Hadoop HBase. I worked with Accumulo. I worked with Neo4j.
Oh.
Cassandra and MongoDB, I'll just make it basic discussion, and with Uzi, I'll just make on with a basic discussion. And I'll delve deeper at the range of MapReduce, delving deeper at the range of Hive, Peg, Scoop, and I'll discuss one of the most powerful ecosystem components, that is nothing but Impala, which is 20 times faster than Hive and Pig.
Oh, okay.
We'll delve deeper regarding those things. And at last, even I'll share about the machine learning, on which I'm working on currently.
Okay. So it will be like a practice session also, or just
Definitely. No, it will not be theoretical. The first 5 days, let me share you. First 5 days will be completely theoretical, where I'll talk about the architecture, data flow in Hadoop, how a file will be uploaded, retrieved, how the data will be processed. I'll address about them. On 5th day, we'll be installing Hadoop on your laptop or on your PC. And once it was installed, we'll start with a simple discussion of a word count program, the very basic program, and then I'll talk about how to generate recommendations through MapReduce, and then we'll talk about how to process a directory through MapReduce, and then with processing log files through MapReduce, image counters through MapReduce, where you can have a peep through this. These are all the examples that I'm going to discuss. So these are all the URLs which we're going to process. And these are all the log files, web server log files, which we're going to process. And even the test environment we'll go on with, and processing a directory, all things will delve deeper. And even I'll share you how to process the JSON datasets with Hive.
So I don't have any industrial experience. So do you suggest me anything so that before starting our course,
not required exactly. Not required, because Hadoop itself is an emerging technology. No one will expect you to be a master on top of anything here. What all they require is a combination and a way to handle those ecosystem components successfully.
Yeah, that's it.
Yeah. Any more from anyone still?
Yeah, I mean, from my side it's good.
Right. So we'll meet later and still continue our journey then.
Yeah.
Thank you.
Thank you very much. Thank you.
Thank you all.